Hello everyone, welcome back. Next we discuss SLR1 parser. In the previous video we have discussed about LR0 parser. In that LR0 parser I have considered the example or grammar like S implies A implies. The same example I have considered here to construct SLR01 parser again. Okay, so before constructing SLR1 parser, I'll just construct once again transition diagram for LR0 parser. Okay, and then I'll show you the difference between LR0 and the SLR1. Okay, so this LR0 and SLR1 both are almost same with slight difference. I'll tell you what is the difference. To construct LR0 parser here, we have to first consider the augmented grammar. To take augmented grammar, we are going to introduce one new production, that is S dash implies S, S implies A implies A, and A implies B. So this becomes what? Augmented grammar. So for the given grammar, this is from these three productions are same as in the given grammar, just we have added one new production. S dash implies S. Here S dash act as a new start symbol for this augmented grammar. Why we have to include this production S dash implies S? In order to hold the string or language which is generated by this, in order to show the accept. Why? Because here we are constructing bottom-up parser from the given string. So finally where we have to reach? We have to reach the root node, from leaf node to the root node. So that's why we are going to include this new production S dash implies S. Once if you include, this entire grammar becomes the augmented grammar, that you know already, augmented grammar. So from this augmented grammar, let us consider or let us write the canonical collection of LR0 items. So to write the LR0 items, what we are going to do? Just we write for the augmented grammar, we are going to just introduce dot in front of the symbol in the right side body of the production. So now the dot is present in front of this S. So now this dot act as a closure of S. So when it is a closure of S, so why? Because closure of what symbol is here? Closure of. If it is a variable, what we have to do? We have to include the respective production. So here the symbol is a variable, the dot is present in front of the variable, we have to introduce the production of S, that is S implies A. Then put again dot here. Where the dot is, again dot is present in front of A. Again A is a variable here, write the respective production of this variable A. What is the production of A? There are two productions, A implies A dot, and one more production dot B. Again the dot is present in front of the terminal A and the terminal B. So now you know that the terminal does not yield or derive any right side body of the productions. So now these are becomes canonical collection of LR0 items or LR0 items. Okay, so from this again we are going to construct transition diagram. So why? Because the dot is present, so the dot is going to see either it is a variable or terminal, it is going to scan or read the symbol. So now the dot, after reading this or after seeing this start symbol S, where it goes? Dot will move towards one step towards right, that is S dot. So now this is dot reach at the end of this production. So now this state becomes or contains the final item. So next come to the next production, S implies dot A. Then A, after seeing A, that is S implies A dot A. Now the dot is present in front of A, then write the A production. A implies dot A and A implies dot B, right? Next, after seeing the input symbol A, then A implies A dot A. again dot is present in front of A, then include the A production, right? Next, finally, after seeing the input symbol B, A implies B dot. Okay, so in the previous video I have named these states as I0, I1, I2, I3 and I4. Okay, from the state I0 we have 4 transitions. Next, coming to the state I1. In the I1 state, the data is reached at the end. It is not going to see any input symbol. Okay, so no transitions are taken place from this state. And come to the state I2. I2, in this all items, the dot is not reached at the end. So now still the dot is going to read this variable A. After reading this variable A, where the dot will move? At the end, AA. So again the dot reached at the end, so this also becomes the final state or final item. No transition will take place from this state onwards. Okay, and one more transition from the state I2 on input symbol A implies A dot A. Again A is where A is, A implies, right, dot AA and A implies dot B. So now these items are same as state I2, right, same as state I3, right? These state items are same as in I3. So instead of taking one more new state, we can give it this transition to the state I3. We can give it this to the I3. Okay, and next, one more transition from this state I2 on input symbol B. On input symbol B, after seeing input symbol B, again the item will be same as state I4. Give it a 4. Okay. Next, come to the state I3. I3 on input symbol A, right? So A implies A dot. Reach the end. So this again act as a final item. No transition will take place from this state. Okay. And after seeing the A, again it is going to give same items. Okay, so same items I can give it to self transition on input symbol A, and then to on input symbol B to state I4. Okay, any other transition? No. So this is what the same transition diagram we have constructed in the previous video by considering the same example. Okay, and also we have discussed how to construct LR0 parsing table. You know that the LR0 parsing table or parsing table, either it is for LR0 or SLR1, LALR1 or CLR1. It contains what? Action and go to table. So action, it includes both the operation. What is that? Shift and reduce. You know that. It includes shift and reduce. Okay, so now this action table, it includes only the terminals which are present in the given grammar along with the dollar symbol. Why we have to include dollar symbol? You know that whatever the language which is generated by the given grammar, that should be end by the dollar. So along with the string, it also includes what? Dollar sign. So now that's why we have to take dollar in the action table. Okay, action table. And go to, it consists only the variables. Okay, so why we have to consider variable? Why? Because in the flow diagram, in the data flow diagram, the transition takes place on both variable as well as the terminal. So again, when I want to move to the state to I1 or to the state I2, I have to see what? The variable yes or A, right? So that's why we have to take one more transition, one more table. These S and A are not includes in the language, or we are not considered as a terminal. So that's why we have to take one separate column and name it as a go to. It includes only the variables. Whatever the variable we have taken on the transition, those variables will be included in the go to table. Okay, so rest all terminals will include in the action table. Okay, so first complete the LR0. So here in this complete parsing table, I have considered both the action for LR0 and SLR1, so that easily we can differentiate and you can understand the major difference between LR0 and the SLR1. So first here what I am going to do, I will just complete the parsing table for LR0. So here action I have taken 2 times and considered go to only 1 time. Why? Because for LR0 parsing table or SLR1 parsing table, this go to is common. Okay, so now let me complete first LR0 parser table. So here it includes what? States, right? This column includes states. These states are common for LR0 and SLR1. I'll tell you the difference. Okay, so from the state I0 on input symbol, yes. So what is the input symbol? Here it is variable. Where it is going to the state 1. So if it is a variable, I should consider which table? Go to table. So it is going to, on input symbol is going to state 1, right? Next, on input symbol A, from the same state I0 on input symbol A going to the state 2, and on input symbol terminal it is going to right I3. So here when it comes to the terminal, we have to consider the action. It includes both shift and reduce. So here when it is seeing the input symbol A and the items which are present here is not the final item, then we have to consider the shift. I'll repeat once again. When you are reading the input symbol from the so and so state, if that state does not include any final items, then you have to write shift. If not, if the state contains the final item, then you have to write the reduce. Okay, so here in this from the state I0 you are reading the input symbol A, but this I0 state does not have any final item. So that's why you have to write shift to which state? State number is 3. That is from the state I0 on input symbol A is I3 shift. I think you have understood why we have to use shift here, right? This state I0 does not have any final items. That's why we have to use shift here. Okay. And next, on input symbol B. On input symbol B, where it is going? Going to the state I4, right? Shift 4. Then come to the state I1, right? I1. Let me take first I2. I2 on input symbol. How many transitions I2? I2 is having 3 transitions. 2 transitions on input terminal and 1 transition on variable. So that is the state I2. I2 on input symbol A. Where it is going? I2 on input symbol A. It is going to the state. Let me name I5 and this is I6. Right? It is going to I5. On input symbol A, it is going to where it is going? To the state I3. Shift 3. Why? Because this I2 does not have any final items here. And on input symbol going to the state yes 4. Okay. And next come to the state I3. I3 again it is having 3 transitions on input symbol A. Where it is going to the state 6. And I3 same on input symbol A, same state, that is a self transition. And on input symbol B going to the state S4. Okay. And next consider the state I4. So I4 it contains only the final item. It doesn't provide any transitions. It acts as a final state. Act as a final state. I4, I5 and I6 are act as a final states. If there is a final item, any state contains the final item, then you have to use the reduce action. So from the state I4, what is the final item? A implies B. Okay, when you are going to write the reduce, you have to write that production number. Okay, from the given grammar, first you have to let us number it. This first production is 1, 2 and 3. What is the number for this production? Which production is present here? A implies B. What is the number? Is 3. This state contains final item, right? Then you have to write the reduce. So when you are going to reduce with the number 3, so you are constructing LR0 parser, right? You are constructing LR0 parser. So now when you are going to write the reduce, you have to write the reduce under all the terminals which are present in this action. That is, number is R3, 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 like this. Okay. Similarly, I5. I5 S implies AA. What is the number? Number is 1. You have to write all the terminal columns. R1, R1, R1. And last one, I6. I6 is the second production. R2, R2, R2. So this is complete action table for LR0. Okay, action. Now I'll show you the difference from LR0 to SLR1. Okay. So next, in the SLR1, when you are going to write the action table for SLR1, this SLR1 and go to. If I consider this, it becomes the complete SLR1 parsing table. If it is if you are not considered this, then this action and go to is for LR0. Okay, now I am considering this. So now, as I said already, this go to always go to will be common for both LR0 and the SLR1. Okay, now no need to touch the go to because we have completed the go to, right? So now you are in the action table for SLR1, it includes only the shift and reduce action. So what are the similar factors for SLR1 and LR0? For SLR1, go to and shift operation will be same. Okay, for SLR1, go to and shift operation will be same. Okay, there is the major difference between LR0 and SLR1 is only what? Is in the reduce operation. I'll show you. Okay, so now 0 on input symbol A. 0 on input symbol A. So for SLR1, we are going to consider the same transition diagram. We'll consider the same transition diagram and the same grammar. Same transition diagram. Whether you construct LR0, SLR1, this transition diagram will be same. Only it changes in the parsing table. Okay, so now here as I said, shift operation for SLR1 is also same as LR0. So I'll consider the same. S3 I'll write as it is. Only shift operation in SLR1. S3 here also S4, S3, S4. Okay. So now reduce action. When you are going to reduce, come to the state I4. I4, it contains what? A implies B1. A implies B1. Then the production number for that is 3. So what is the reduce number is R3. Where I have to write R3? In LR0 we will be writing R3, that entire row. But in the SLR1 it is not like that. We should not write in all the terminal column. We have to write only the follow of that variable. So it means when you are going to write or reduce for SLR1, you have to calculate follow of that variable. Whatever the variable which is present in the left side of that final item production. What is the final item production here? Final item production is A implies B dot, right? So now I have to calculate the follow of A here. Follow of A. So first we calculate first and follow for this. Okay. What is the first and follow for this grammar? First of S is equal to what? First of S is equal to what is the first symbol which is present in this body of the production is A. That is first of A. Here it is what? Is it variable or terminal? It is a variable. So now I have to calculate in the right side body of the production of this variable. What is the first symbols which are present in the right side body of the production? That is a comma b. So now the first of s is equal to a comma b. Next, first of a. What is first of a? First of a is a comma b. Next, calculate follow. Follow of s. Follow of s. When you are calculating follow of s, if that s is a start symbol, what you have to do? First you have to include dollar, and then you have to check it anywhere in the right side body of the production, is that symbol is present or not. So in the right side body of the production, the start symbol s is not present. So it includes follow of s, it includes only the dollar symbol. And then next variable is follow of a. What is follow of a? Follow of a, here the follow of a here it present. Follow of a. After that, what is the symbol present? The same variable, right? The follow of a. Here it is, a is present in this right side body of the production. Follow of a. After this symbol, what is the symbol is present after this variable? Is again same symbol. That is, I am going to calculate first of a. Follow of a is first of a. After this no symbol is present, then I should move on to the left side symbol, that is union follow of s. What is first of a? Here we have calculated first of a is a comma b union. What is follow of s is dollar. So now follow of a is a comma b comma dollar, right? Follow of a is a comma b comma dollar. So now when you are writing constructing SLR1 parser, the reduce here follow of a is a comma b comma dollar. So under a, b and dollar you have to write this production number. So what is that? R3, R3, R3. Don't get confused here. Okay. So here LR0, in LR0 we are not calculated follow of that variable. So whatever the number is there under all the columns, we have just directly written that reduce symbol in the entire row. But here in the SLR1 we have calculated the follow of a. For follow of a, here we have got the same terminals a, b and dollar. So that's why we have written all the three terminals below, all the three terminals R3, R3, R3. Okay. And next, what is the next item? I5 is s implies a. So here calculate the follow of s. What is the follow of s? Follow of s is only the dollar. So under the dollar you should write the production number. What is the production number? Is R1. So here under from the state 5 and under the column dollar you have to write only R1. You have to write only R1. Okay. And next I6. I6 again here it is left side variable is a only. When you calculate follow of a comma b comma dollar. So under that you have to write this production number R2, R2, R2. Now you compare, right? So here LR0 and this is SLR1. So LR0, SLR1 almost shift and go to are same. Only there is a slight difference is in the reduce. So here the reduce we write entire row. Here in the SLR1 we calculate the follow of that left side variable. Then whatever the terminals we got for that follow, so only under that column or under that terminal column we are writing the reduce. So this is about SLR1. So let us consider one more example to construct LR0 and the SLR1. I'll consider some other example.